Use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome to WebRTC Live. I'm your host, Aaron Syme, founder and CEO at WebRTC.Ventures. In today's episode, we'll be talking about agentic workflows that work in production. But first, let me remind you that our team at WebRTC.Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. So thank you for joining us live today on YouTube, LinkedIn, and Twitch, and welcome also to anyone watching a replay of today's event. And you can ask, if you're live with us, you can ask a question at any time throughout the stream by leaving a comment in whichever platform you're viewing this. Today, I'm joined by two of my colleagues here at WebRTC.Ventures. First up, our Chief Operating Officer, Mariana López, is here, who has also hosted WebRTC Live in the past. And in addition to her expertise in leading our company, she also has a wealth of experience in UX, application design, and customer discovery. Welcome back, Mariana.
Hi, Aaron. It's great to be back. Thank you for having me.
Always good to have you here on WebRTC Live. And next up, we have another return guest, our CTO, Alberto González, joining us today. Alberto has deep experience in real-time communications applications, has been a leader to our teams working with WebRTC and AI integrations for a wide range of use cases. Welcome back to WebRTC Live, Alberto.
Hi, Aaron, and nice to be back as well.
Excellent. Good to have you both here. We're going to start a little bit with Mariana. Mariana, LLMs alone, we know, can't act on their own. They generate text, right? To put it very crudely and simply. So how do you move from the text response of an LLM to an agentic workflow that can take action in the real world?
I think when you do that, you have to think about what are the strengths of the LLM generating text, and how can you add that into a workflow that has knowledge bases, that can perform actions, give it the right tooling. But also, when you do that, when you give it more power than just generating words, how do you also enable guardrails, observability, and you make sure that you test everything in a production environment? So it's essentially embedding something that can create into an existing workflow and giving it just the right amount of context and just the right amount of tools.
Yeah, just the right amount of context and just the right amount of tools. That sounds like we're going to have to architect something here. So how do you move from a conversation to orchestration of an application? What does that look like?
Great. So
yeah, I can answer that. I think there are different kind of architectural patterns you can use, but in a more higher level, you need to consume that media and be able to process it through specific frameworks that we use. But yeah, maybe Mariana can give a bit more details into how we have done it in the past.
Yeah, and then you might jump into all the different architecture patterns, but we can explain this simple use case. So we wanted to ground it on something that is common and typical, which is in the finance world, which is asking for a loan. And it's important that we ground it in a use case so that we understand where does it make sense to have trade-offs and where does it make sense to add different tools and different parts of the environment. So if we walk through this use case that we created, we have a human calling an AI agent that answers. And this AI agent is sort of like your receptionist. He has just enough context to understand why people are calling and just enough to know who he has to direct that call to. And we have an agent that's an orchestrator that will then direct to the right sub-agent to handle it. So in this case, this person is asking about a loan. We're going to send them to that sub-agent so that it can explain what's the process, how do you input. In this use case, we also use a form for input instead of trying to have a phone conversation, which we all know that is very painful, whether it's AI or human. And we also added in a decision rule engine to be able to check if you're approved for a loan or not. And this is based on a rule set, and it's deterministic. So you don't want an LLM making those decisions for you. You want to make sure that that answer is repeatable and that you always get the right choice. And we also added in this use case, a human in the loop, because there's certain use cases that is not clear cut if that person should be approved or not. And we want to be able to always have an escalation path and a human being able to review the case and make the right decision with all the data that we've gathered in the previous stages. And of course, what you always want, which is the outcome. It's always important to not forget why we're building these systems, why we're architecting these solutions. And in the end, you want to have the ability to say, well, this loan was approved, it wasn't approved. And you also want to be able to have feedback and understand why that was the case. So this is our use case, but Alberto can explain a little bit more about the full patterns that we have.
Yeah, and before we get to those patterns, let's talk a little bit about this too, because this is an example. You know, we'll have a little demo and talk more through this specific use case later on. But it's an interesting example because, as you said, Mariana, what you want is a combination of the benefits of LLMs, but they're non-deterministic. So you're also building in some rules engine work, and so that you have more repeatable and deterministic outcomes. But also in that diagram, it looks like you have kind of multiple sub-agents working in parallel in that diagram. So I wonder if one of you can talk a little bit more about the risks and benefits of sub-agents. What types of tasks would you give that versus, say, a rules engine?
Yes, so I can speak to that. Usually you divide that in sub-agents, so they have very specific objectives, each of them, and they are allowed to interpret and propose actions, but they cannot execute them directly. No, so they you might have a sub-agent that is in charge of the welcome stage of the interaction, and the main goal of that agent is just to welcome users. So that way you can guardrail them and you can control exactly how they work. So by having these sub modules, it's a bit easier to test and easier to have a bit more security in the system. The challenge is that obviously it's like the same idea with software architectures, no? Like you can have microservices like approach or more like a monolithic approach. So this is kind of similar, but for AI.
Yeah, so still a separation of those concerns. So you've got more discrete parts, even if they're an LLM or an agent that you can test against. So that makes sense. How do you, Alberto? How do you mitigate hallucination in those sub-agents?
Yeah, so I mean, there isn't like a 100% solution out there, but we treat really hallucination today as a control problem and not as a prompt problem. So it means like it's not just about telling the LLM, please, please, please don't hallucinate, or please, please, please never answer this or that.
Right.
This is never going to work because, well, probably everyone knows like that sometimes fails, sometimes they hallucinate. So what you do then is have this separation and have a reasoning stage, which is the LLM, and an executing stage, which is just built by code. So you basically will have maybe a decision table, will have maybe a specific software. You don't need to have a table, could be just a flag, just some software, some policy system. It can be many ways to do that, but basically some way to rely on something else to make decisions. And an example could be what we were having in this case, for example, escalating to a manager, let's say, like we have to decide if a call needs to be escalated or not. And that could be, that cannot be decided by the LLM, because it might hallucinate. It might decide that some code that shouldn't even reach us out needs to go to the manager. So what we do then is some kind of intermediary process where the LLM decides that wants to do this, but it's requesting a policy engine what to do, and it will say if this call has a specific risk level, is at a specific stage that we should escalate or not. So this software basically that we write will decide it, and it's deterministic, and will give back the LLM if it can perform the action or not. Only if those rules pass, then we will perform. So that's one way to mitigate hallucination and avoid harm, especially in regulated industries. Like if you are talking about even credit cards, that's even more dangerous. But that's why companies today, like large companies, are using AI, and that's one approach they follow. Not rely on just LLMs.
Yeah, that makes sense. And there's a lot of reasons that AI projects fail, right? And it's kind of commonly discussed. It was talked a lot in 2025 and last year about how many projects are failing, and they might fail for technical reasons, or maybe being unable to figure out a way to control hallucinations, for example, and what you just described, Alberto, maybe a poor architecture that doesn't define those boundaries correctly between like a decision rules engine versus what you let a more freeform LLM do, that type of thing. But even beyond that, for any project, but especially AI work, to be successful, we really need to talk first about how do we frame the problem that we're trying to solve, and what are the value propositions that we're offering to our users. So, Mariana, can you talk a little bit about how you do that up front in a project?
Yeah. And at the start, there's always this craze for new tools or new technology, and everybody rushed to create the AI chatbot. And we have to stop and think, well, is this really going to make our user's journey better, or are we just building for the sake of building? And you have to think about, where are our pain points? What are the friction points that our users are really feeling? And and when you have real pain points or things that don't you haven't been able to solve, then you can start thinking, well, is AI the right technology here? And there's a great amount of use cases where AI is amazing at coming in and changing the landscape, right? Data collection, aggregation, finding patterns, verifying documents that used to take a long time. um, uh, Reducing wait times, right? We build voice bots, and we want to make them great, and we want to be able to have those kinds of receptionist AIs that can lead us somewhere. But then you also have to think about, well, does it make sense? Does it make sense to change a form where you can have where you can make sure that everything that you're writing is best, or does it make sense to make it through voice? And I think that that's where a lot of us fail, in thinking LLMs can solve everything, and not thinking, well, what is the real pain point here? What are we trying to solve? And then let's find the perfect tool for each of the pain points that we have and combine them. And I think that that's where it is really important that you have a technologist that can help you and that can help build the solution for you, because they will know. They'll say, okay, this is a perfect use case for AI. We can build this in. But then you also have to think about, how do I add guardrails? How do I make sure, that it's not approving all of my loans, or that it's not escalating when it has to, it's not hallucinating. And I don't want to forget the part about testing and making sure that the solution that you've built is really cohesive and can really be put in production, and it doesn't have any huge security flaws.
Yeah, for sure. So Rafael asks, what do you think gets in the way the most? The tech, the process, or the people involved?
I think it's
Oh.
it's a combination. I would say a lot of what's happening now is expectations are shifting. It becomes really easy to see something that looks polished and perfect, and underneath there's no ground to stand on, or the architecture or the orchestration wasn't made carefully, and that causes it to fail when it's put to real load or real test. But then I also think a lot of it is people trying out new technology, new things, and not going back and thinking, does this really answer a problem? Does this really solve something that we want to solve, or are we just following trends and following product? So I think it's a little bit of everything combined.
Yeah, for sure. And by the way, you know, when we talk about agentic workflows, and a lot of what we're talking about in this conversation today could be used in a wide range of type of LLM driven applications. In our work at WebRTC Ventures, we're specialists in voice and video applications and real-time communications. So we tend to be more focused on how do you integrate that LLM agentic workflow with something that also involves real-time communications in some forms. So when we talk about like WebRTC and voice and video specifically, question for either one of you: what are some common use cases that where you would want to combine in real-time communications in an agentic workflow?
So, I mean, there are some exciting ones we have worked on that I think we can share in a very high level. Some related to really simulators. So you can think of like simulate humans for teaching scenarios, for sales. Actually, our first, I would say, AI project was years ago, was about like a co-pilot assistant really helping sales agents be able to sell better. So that was one that actually was quite interesting because while they were talking, they were assisted by AI and were getting suggestions based on the conversation. More recent ones, as I was saying, like are more about maybe training a specific person on how to deal with a specific kind of user, patient, you name it. Like there are many of those, and of course, yeah, customers support. I think that's also a pretty popular one. I think those are the ones that are more common. I think, but I don't know if maybe there are more original ones out there.
Yeah, no, I think that makes sense. And what's interesting is, you know, we're talking about how do you, like, what's the value that building video into a business tool you provides for you, right? And that's something we've talked about for a long time at WebRTC Ventures. It's not just about building meeting tools, because they're off the shelf ones that you can use for standard meeting scenarios, right? And you don't need to build something custom. But but when you have a custom business process that benefits from building that video and voice into it, so you can tie it into your data, that's where value starts to be added. And we've done work along those lines for a long time, but now that extra architectural component of building in an LLM into it makes it much more conversational, and you go well beyond just, you know, grabbing a transcript of a call in real time and doing keyword searches to try and pull up the right, you know, data from your system to help the sales agent. Now the LLM can do that much more intelligently and tap into that system too. So maybe that's a good point for us to kind of move to, you know, both referenced earlier that there's some different design patterns that Alberto, you can talk about that people can consider as they work on agentic workflows. So let's talk through some of those.
Sure. So yeah, these are like, again, patterns that I'm not sure they are in like a very specific or well known by everyone, but they are patterns that we have been able to see in our projects, and many times they are combined, so they not necessarily one or another. But yeah, the first one is the one we have seen for longer, the traditional question answer kind of flow with FAQs, where you would go to a website and there would be some kind of bot that kind of automates the FAQ search, and you would ask a question, it would be able to answer. So those are very simple. They are pretty easy to implement. Not something we have done a lot really, because it's pretty simple to do. And today with OpenAI, you can do it in a day. Then there is the additional step that follows up on that. It's the addition of RAG to it. So it just, instead of just a small chunk of text, in this case, you are adding a lot of information. Sometimes can be thousands of pages, although with some performance implications. And those can provide more insights. These are common, for example, for all those AI agents that when you go to maybe if you are a developer and you go to use a specific API, there are starting to be some companies already having an AI agent being able to help you create snippets of code or search a specific information about the API just directly with the bot. And usually that will involve RAG. Then there is the third step, which starts to be a little bit more complex, but more useful, the multi-agent approach. This means specialized agents collaborating like a small team, works like a pipeline. So one agent moves the conversation to another. And the challenge obviously is the coordination of it. It's a bit more complex to build, but an example is like the fraud use case or an onboarding flow for a user, stuff like that. Then there is the human in the loop, a super popular pattern. I would say is almost recurrent in our projects, and it's required for escalation and approvals, and to reduce also compliance risk if there are some decisions that definitely need to be done by a human. And the last one is the event-driven agent. That's a bit like common in our use case, because it's just about having maybe a conversation with a AI agent while the AI agent is performing actions. And we built a similar system using that for sales enablement for a company called Ava, acquired by Woza last year. And initially, we built it first just for conversations, but we saw that there was much more value if we could perform additional actions. The lesson really was just that a conversation doesn't give you a lot of value, and the value comes from those agents being able to operate with external systems or perform asynchronous web search, marketing research, things like that. But yeah, those are some of the design patterns that we have seen, and usually we combine all of those.
Perfect. Thanks, Alberto. And Mariana, we have a little demo that we'll show here, a recording of in a moment, that gives people a sense of what a workflow, what type of workflow we're talking about here in a customer context scenario. Tell us a little bit more about what we're about to see.
Great. Yeah. So this demo is simple. We built it in a very short amount of time, just to showcase an agent, multiple agents interacting, multiple different types of inputs, and a decision rule engine underneath. You're gonna see an example where everything goes well. We did have an escalation path, but we kept it simple for the sake of time. So yeah, that's just it.
Perfect. All right, so we'll see a little example here of that.
This is Alberto. I'm calling about a loan to repurpose my house.
Hello, Alberto. I can answer quick FAQs about our pre-approval program or connect you to our loan specialist if you'd like. How can I assist you today?
Please just connect me to your loan specialist.
Connecting you to Blake, our loan specialist. Please hold for just a minute.
This is Blake with AgilityFeat Lending. We'll start with a soft credit inquiry that won't affect your credit score. May I please have your full legal name to begin?
Yes, it's Alberto González.
Thank you, Alberto. Could you please provide your email address so I can send you a secure application link?
Yes, it's Alberto at AgilityFeat.com.
Thank you for the information, Alberto. I'm sending the secure application link to Alberto at AgilityFeat.com now. Would you like to stay on the line while you check your email?
Yes, please.
Take your time, Alberto. I'll be here when you're ready to proceed.
Okay.
Excellent, Alberto. If you need any help with the application, feel free to ask. Otherwise, I wish you the best with your pre-approval process.
I have a question. Why is the form asking for my social security number?
We request your social security number to accurately perform the soft credit inquiry and verify your identity. This helps us provide you with a tailored loan pre-approval without impacting your credit score. If you have any concerns, I'm here to.
Thank you.
All right. So, Alberto, talk to us a little bit about the architecture of what we just saw.
Sure. Yeah. So as Mariana mentioned, is in this case is a simple demo. So typically would be a little bit more complex, but I think it covers the main aspects of voice AI conversation. And this demo involved using particularly real-time voice AI framework called PipeCat. And it's pretty powerful because it allows you to use transports like WebRTC or WebSockets. So you can just get audio and be able to convert it through third-party platforms to text and then leverage large language models. It also allows you to use many different third-party platforms. So that was the decision we took here to use that open source project. We in the past also have used similar ones like LiveKit, but those two I would say are the, at least that we know of, the most popular ones that work pretty well for voice AI use cases. And in this case, we also use third-party decision system called Decision Rules, and this is what decided if the user was allowed to get the credit or not. So that aspect of the process was handled out of the LLM, and the rest, the conversation was in the like handled by the large language model. Yeah, so we use also some third-party frameworks for speech to text, for example, DeepGram. There are many. We have also used open source Whisper, but we kind of simplified this to use third parties just to build something quick. And yeah, that's I think a quick summary.
Perfect. And we have a question from Justin, who wants to know if you've looked at output quality across models like GPT, Gemini, Opus for agentic workflows. What's your sense about kind of the quality across those different models, and how would you architect that into an orchestration framework like this?
Yeah, I mean, quality is a bit subjective. Like no matter who you ask, everyone will have their preferred option. But I think it varies also. There are all these tests out there that evaluate from different points of view how these models perform. Some are very good now at code. We know others are for math, others for conversation, others are more polite. You name it, like there are all these tests. So I think it's a bit about finding the one that fits what you want to build, that fits also the cost, of course, of what you want to do, and in terms of latency. So I would say, yeah, it depends. As a consultant, that's the typical answer.
Right.
But yeah, I would evaluate for the specific use case, like see what's the latency you want. More sometimes better accurate LLMs are slower. So yeah, it's we haven't we don't have like a preferred option that we think it goes well with everything. Yeah.
Yeah. We work across models because it
Yeah.
does depend on the use case. And generally speaking, I think that's what people ought to consider in their architecture and building applications too. Is even if you're focused on a particular model now, at least architecting your applications so that in the future, when some other model comes around that maybe is a better fit for your use case, you have the ability to swap one in out for the other without your users realizing it, other than maybe things just got better in the quality of responses that they got, right? But that they don't see that technical change. So building that in helps address that. But it gets to another issue I wanted to ask you about, which is that one of the challenges of working with LLMs is that they are non-deterministic. You're never going to get the same answer, the exact same answer twice. And in a way, that's similar to what we're used to when working with human agents, if we're talking about like context scenario type of scenarios. So in a sense, LLMs mimic reality in that way. But nonetheless, we need to be able to audit and measure success. And we also want to be able to create repeatable tests. And as we're building these things, in order to measure that success over time, we need to have some kind of repeatable test framework or way to test them. So how do you go about building tests, let's say, for a non-deterministic system that's based on LLMs?
Yeah, so it's complicated. I don't know about a popular framework that exists today for voice AI automation testing that is specifically focused for this, at least that I know. So what we usually do is it involves custom app development. We use, of course, frameworks that do automation. Like there are some like Playwright, stuff like that, that helps to do automation testing, but they are not built already out of the box, ready to generate random voice conversations and hit a specific agent with it. So yeah, we would build those scripts and integrate with the specific framework we are using. So it also depends a lot on, like, if you are using Gemini, you are using some voice AI frameworks. For example, LiveKit has a tooling to generate audio streams via CLI. So you could use that to send audio streams to the server, to the agent. And in advance, you could create pre-recorded synthetic audio conversations just to randomly test and record those results. So it's a bit of a manual development process to get that nailed down for the specific project. But yeah, that's the process.
Makes sense. Yeah. So let's talk a little bit about as we're coming to the end of our time here together. So as we start to wrap up, I want to make sure we talk about the differences in doing this in like security and privacy sensitive industries like health tech and fintech. And so we just gave our example application in this conversation has been someone talking to a contact center about a mortgage approval, right? So obviously there's financial issues and privacy issues around that. We've done work in healthcare before, certainly lots of security and privacy issues there as well. So Mariana, what kind of extra concerns should people consider as they're building things for those industries? How do you build in things like security and observability?
Yeah, and here it's really important that you think about the user that's going to be calling in and the data that they're going to be sharing via audio or voice, and your level of comfort and the level of security that you need to add in. Another thing that we've shown, for example, in this example, is we use a lot of third parties. So what are your agreements with those third parties and how do they handle the data? And then at some point, companies have to make the decision, well, I'm not comfortable with them having PII data about my users, or I am comfortable because I've signed the agreements. And so it becomes a little bit less about technology, more about process, but you do have to think there's different ways of safeguarding the data, but but they do get more complicated, and you do have to take into consideration third parties and other systems that are assigned. But Alberto can talk a little bit about what you can do with security.
Yeah, so I can talk from the WebRTC perspective or the real-time perspective. The danger is that you are sending wherever is being set by the user directly to a model. So is obviously a bit dangerous now. Like that PII information could be already captured by a third-party model, then sent to another LLM that's another third party. So it's PII information going everywhere, and obviously someone could even hack that model provider and get access to it, which would be horrible. So you want to make sure you block that from the beginning. There are different ways to do it. I think what we use ourselves is leverage the STT model provider, the speech-to-text model provider capabilities to make sure that we are redacting PII information. And if you don't trust, that's one approach. And if you don't trust the STT model provider, you can also host your own speech-to-text model and add PII redaction at that stage. So it would be the first step. The user is sending encrypted audio to wherever the speech-to-text model is located. And at that point, you are already redacting that. And from now on, that is not getting into any other system. And then the LLM is dealing with that as a placeholder. So if I'm saying my personal email, that personal email could be redacted as well, or my SSN could be redacted, and the LLM knows that placeholder is like a SSN number is what the LLM would see, basically. But yeah, that's on the redaction and encryption part. Of course, the typical logging, monitoring stuff needs to be built in as well.
Perfect.
And just one more, of course, it's listed on the slide, but I think it is important, which is good architecture, making sure that there's guardrails for prompt injection or agent manipulation and out of scope conversations, which we've talked about previously, but I don't want to let the slide go without mentioning that that's really, really important.
Guardrails, guardrails, guardrails. Key part of all of this. We have a couple other viewer comments and questions I want to close with today. So we have one comment here from the user that you can have a model downloaded and uploaded to your private cloud, and then follow on comment and then make API calls to it to retrieve the responses. Alberto, any comments on that?
Yeah, it's very open. We can have, I don't know if he's referring to having like our custom model, or if you
yeah, I think referring to just having a local model and kind of, instead of using one of the services, having
yeah, so it's possible to run today. You could run everything local in your computer. It would be very slow unless you have like a really powerful machine. But it's possible. There are even some capabilities that could be done today in most of the computers. Like if you wanted to do, for example, recording, transcription, key summaries, this kind of stuff could be done on your computer. And that's actually generative AI, because you are parsing the transcription and you are getting the key action items, stuff like that. So this with small models is possible today. But yeah, for more accurate or powerful stuff, generally we run it on the cloud. And yeah, if we want low latency, what we have learned is preferably using something located in your region. There are some third-party providers actually that perform really well in terms of latency. So yeah, worth considering.
Yeah, So once again, to quote you from earlier, it depends.
Yes.
You may, for security reasons, want to consider that sort of private cloud model. But then again, if you are working in real-time communications with that model and need ultra low latency on a global network scale, you have to implement that yourself, perhaps in that scenario, and that could be much more complicated. So there may be, commercial options that you want to consider for deployment of that, at least. And one final comment, viewer comment here. From a Gartner report, a quote here that AI agents' unpredictability makes it unsuitable for managing high risk or sensitive issues. So when we talk about things in a regulated industry context, how do you assess AI agents, risk management when consulting a client? I mean, we talked a little bit at the beginning related to this, I think, about the combination of sub-agents, but also then being essentially constrained by a decision rules engine. What other things do you think about when you assess that risk management?
Yeah, no, we've seen examples where the guidelines of a company are converted to code, and then they're also given to AI agents to execute. You can have, different levels of agents. So you can have an LLM as a judge, making sure that the previous agent made the right decisions. And my favorite, of course, the human in the loop. I can't not stress this enough, right? There's always a good set of code regulations that will trigger that this is a gray area, this is a warning, we might need somebody to step in and review. Alberto, I don't know if you had any additional.
Yeah, an addition, maybe small one, auditability, like kind of monitoring all that, and having actually something that keeps track in real time of what is happening. So you can track kind of like a high risk conversation in advance or at the time it's happening. So it's when you can trigger, for example, the human in the loop or the policy block action. So I think more specific, like enforcement of policies, as I was saying at the beginning of the call, through software, not through prompts, and then with that you kind of reduce risk, especially if you have auditable track of that. In text usually is easier than voice, and that's how we start, and then you extrapolate to voice.
Perfect. Okay, so a couple of themes that I've got from this conversation then is when you're consider orchestration across sub-agents in order to have kind of like a separation of concerns and spreading functionality around in smaller pieces that can be tested more discreetly, making sure that you are considering guardrails from the start, especially when dealing with sensitive data. As Mariana talked about, understanding what those friction points are with your users and making sure that you are solving real world problems so that even if you get the tech right, you also get the actual like user value right, which is sometimes overlooked when we're putting in a shiny AI object, forgetting about whether users really enjoy the experience or not. And then, yeah, human in the loop, human in the loop. Human in the loop and guardrails, and then final note: if you are doing this around real-time communications, like in our demo here, all of the questions become a little bit more complicated to answer, and because low latency is so crucial when you're talking about voice conversations with an LLM, very different than text-based conversations that some workflows are only based on. So making sure that you're working with experts like us at WebRTC.Ventures who can help you with that low latency integration with LLMs. So for our viewers, if you need any help building agentic workflows that incorporate WebRTC and other real-time communication technologies, our team at WebRTC.Ventures is ready to help. So thank you again, Mariana and Alberto, for joining me today.
Thanks for having us, Aaron.
Yeah, it was nice.
Always. See you again soon. And for all of you watching today, hang on. In just a moment, I'll have Sahi joining me for our industry analysis segment. And in today's conversation, we'll talk about the importance of monitoring CPU usage on the client side of WebRTC calls. So really important to quality of your video calls. But first, let me remind you that this video will be available on the WebRTC.Ventures YouTube channel, as well as on our blog at WebRTC.Ventures. Our next WebRTC live episode will be in February, probably February 25th, but we're still finalizing some details there. But we're planning to talk about one of the most foundational topics in WebRTC, turn servers, and putting together a great panel of experts to talk really about everything you need to know about turn servers. And I bet there'll be some mention of stun in there too, because they always go together. So make sure that you check out that episode to find out the final details on that episode, and to learn more about all of our interviews with WebRTC industry experts. Follow us on social media at WebRTC.Ventures, on LinkedIn, on YouTube, and join our email list at WebRTC.Ventures. So thank you everyone for joining us today, and let's make it live. Thanks for joining me today, Sahi. Call quality is always a big topic in building WebRTC applications, and oftentimes when something goes wrong in a video call, we tend to blame the network first, or maybe the user's Wi-Fi. But today you're going to explain why we should pay attention to CPU usage also. So tell us why that is.
Yeah, so thank you, Aaron. I think if you go to almost any company and ask them, okay, what kind of data are you collecting for your call in WebRTC? The answer will be either nothing, we're not collecting, we're running blind. These are great because we can sell them stuff. Then the other one would be we collect specific metrics that give us everything that we want. And then what they collect is going to be jitter, packet loss, and round trip time. Right. Almost that's it. Maybe bitrate or some other esoteric thing like frame rate, which is nice, but it's not enough. And the third part is those that collect everything and trying to make sense out of that information. And the thing is that the category in the middle, the one that are doing the network, they're capable probably of finding something like 90% of the issues that relate to media quality. Not all the issues about media, but most of the issues about media you can see there. The problem is, well, you know that something is broken, but you don't know why. And that's why we need all of the other metrics, and a lot of them are going to revolve around CPU and not around network. Because once you get to the point that you know that there is a problem, what your goal here is to find the root cause. And root causes are to be found by, figuring out from the data where the problem stems from. Yeah. So I can have an issue that shows up as packet loss. And that issue might be because there is packet loss on the network. Obvious. Mm-hmm. Okay. But it might also be due to CPU load on the sender side that causes throttling, that makes so that some of the packets that he's sending don't go even into the network. His network drive simply throws that away because it's UDP and nobody needs that. Okay, so there are a lot of these types of issues that you say, well, usually the classic approach would be packet loss equals a network problem. Mm-hmm. Not all the time. And what we want to do is to figure out these times and try to distinguish what the root cause of the problem is versus just saying, well, it's crappy video or crappy audio because it's bad. That's it. We know that it's bad. Dear user, we saw that too. Great. What does that mean? How do you help me with that? Yeah. So I dedicated this month, for example, for looking at the CPU. Now, I think that what makes the CPU more interesting than other types of, let's call it, issues that you might bump into with WebRTC is, first of all, it's not under your control at all. Right. It's someone else's machine that you don't know. And even if you do, something else might be running at the same time on the same machine. Yep. I had a client that had an issue that at some time during the day at a specific hour. Usually there were network issues with doing the stuff that he needed to do with WebRTC. When he looked at that, that was a time of day when they did the backup of the machines towards their data center. And that just clogged the network or clogged the CPU or whatever. It caused an issue. Okay, so now the difference between CPU and other things is that you can't just go and ask the machine through the web browser, what's the CPU like? What's the percentage there? Are you 20% full, 80% of capacity? Are you fully loaded at 100% and choking to death? You can't ask it. And the reason you can't is because privacy. Browsers decided that you cannot access that information because it is too private. Why? Go figure. Okay. Usually they do that when you need to deal with fingerprinting, finding out what the user is doing, or trying even to hog his CPU.
Right.
So let's say that what I'm doing is I'm creating a browser extension that does something useless, but along that something useless that I do, I'm going to go and try to generate crypto keys out of that. I'm going to harvest crypto. That requires a lot of CPU. I don't want the user to complain or to figure out that there's an issue in the CPU, so I'm going to check his CPU all the time and understand when the CPU is available and use that time to run my extension. So that's the reason, for example, why not to give users or developers access to the CPU information. That said, with WebRTC, I actually need that. Okay. The classic case when you're choking the CPU is when you try to run a group call. And the first naive solution for a group call would be to say, well, we want the highest possible quality. So obviously, Aaron, what we're going to do is I'm going to send you 1080p resolution at 30 frames per second. Or
everybody in that group call.
2026, we're going to do 4K at 60 frames per second because that's what we do with games, right?
Right.
And everybody is going to send that and receive that because we want the highest quality possible.
Right.
Now, each such stream of 1080p, 30 frames per second is what? 4 megabits of data. If I need to do a call with just 4 participants, not many, I'm going to decode 3 such incoming bit streams. Even if I have a hardware decoder, it might not be able to decode so many streams in parallel.
Yeah.
Okay. So I'm going to kill the CPU. And the thing is that what we're doing, it's like feeding ducks to get their liver at the end. You just stuff things into the browser and tell him, go decode this video. And there is nothing he can do with that besides trying to decode. What's the end result going to be? That if you've got an SFU and it's too stupid and this is what it does, and there are such cases all the time. I get them all the time. So what happened is the poor WebRTC implementation would look at it and it will say, well, I've got an incoming video. I've got a frame. It's too big. I don't have the CPU. I'll throw that away. Next frame comes in. Well, this is a P frame. It depends. It's dependent on the previous frame, but I threw that one, so I will throw this as well. So you end up throwing a lot of video frames on the decoder side so you can actually do other things. And what you'll have is the network is clean, everything is fine, but the frames decoded is different from the frames displayed, that is different from the frames received, that is different from whatever. And the CPU is choked full. Okay, so, and then you're stuck. So we need to figure out on the client side what to do about that. The way to do that is to get hints from WebRTC that things are bad. And today there are 3 ways of doing that. The most classic and straightforward approach is this API called quality limitation reason. Not API, but part of WebRTC statistics. There is a quality limitation reason. In there, the video encoder is going to say, well, in the last second, minute, up until now, whatever it is, 10% of the frames were reduced in their bitrate because of a CPU issue or because of a network issue. So you can say, well, I'm going to check and wait on the encoder. look at that quality indication reason. If it's CPU, then I know that there's a problem with the CPU and I need to figure out elsewhere what to do. WebRTC will be intelligent enough to reduce the bitrate for the outgoing video, but I might want to balance or rebalance other things in the system, or at least know about the problem so I can figure out a way to fix that. So that's one, which is great, until you remember that there is receive-only cases. So what do I do if let's do it here just for, we've never done that before. I'm going to mute my video.
Okay, the network, there's something wrong with your Wi-Fi, Sahi.
No. I mean, it's something that I did on a video call, an actual video call. I muted my video because I wanted to munch something without anyone seeing me. Okay? Or, take a sip of my water.
Right.
Now, during that time, there is no encoder. Or if it's just a receive-only use case, doesn't really matter. So if there is no encoder, there is no quality limitation reason to look at to find out there's a CPU issue. But I still want to know that the CPU is clogged, even if I'm doing only decoding.
Mm-hmm.
And then I start looking at other types of statistics. And the one that is the classic approach there would be the total encoded. Well, I wrote that down for me. I always forget the actual names of these things. The total encode time, that would be the time from the beginning of the call that the encoder worked in milliseconds. Okay, so I'm going to take that value and divide it by frames encoded.
Yeah.
And that would give me the average time to encode a single frame or to decode a single frame, depending on what I want to look at. Total decode time, total encode time, and then frames encoded or frames decoded. So I can glean out of that data information that is either the time that it took to encode and decode a frame from the beginning of the call on average, or in the last minute or second, or whatever time frame I want. I can play with that and do that calculation. What is it good for? In a video call, we usually do 30 frames per second. We said that before, but if I know that I'm running 30 frames per second for this call, that means that I need roughly, I've got like a window of 33 milliseconds per frame. So if I cannot encode within 33 milliseconds or decode within that time frame, I'm screwed anyway.
Right.
Because let's say it takes me 40 milliseconds to encode a frame. I can't do 30 frames per second. Okay. So you might say, well, okay, so if it's 30, we're okay. And the answer is no. What we want as a rule of thumb for the generic use case would be to use no more than a third of the budget that we have for the encoder and the fourth of the budget that we have for the decoder. So that would be roughly for the decoder. Okay. Why? Because we have other things to run on that CPU, not only the video encoder or the video decoder. And again, there might be specific use cases that are different, but that would be a starting point.
Yeah.
Okay. So in a way, what I'm trying to say is this. We've got the statistics in WebRTC. There is a lot of data there, a ton of data. If you want to build something intelligent that works in all scenarios and cases, you need to look at the CPU as well. In order to do that, you need to dive and dig into the WebRTC statistics, run a bit of math in there, and then from there, deduce what is the current CPU state, because you cannot just ask, well, what's the percentage of CPUs at this point in time?
Yeah. And I think, so this is really helpful insight, because we do tend to blame the network first, and problems may exhibit in network behavior like packet loss, as you said. But we can't control the CPU, as you said. And so when you detect that there are problems, that there's CPU starvation going on, or whatever may be the case, how do you react to it? What decisions should you make in the code? And do you recommend looking at this as kind of like a post-mortem analysis of a call that went wrong, looking at the data, or looking at this in some constrained time window during a call and taking action during the call to try and improve things?
First of all, that's a great question, and the answer is yes.
All
Okay,
of it.
you need to
do it all.
You need to do both. Okay.
Yeah.
The first thing is there are things that we need to do, and that would depend on the exact use case and scenario that we have.
Yeah.
So, for example, if this is running on an SFU call and this is a group call, and I've got 10 incoming video streams, or 16, or whatever it is the number, because I wanted to do the 24 squares or whatever of a lot of small tiles on my screen. So the first thing that I would do is go from 16 down to 9, go from 9 down to 4, go from 4 down to 1 or 2. Just reduce the number of tiles. That's easy. I can say, well, you know what? I'm going to limit the encoder. Instead of 3 simulcast layers, I'm going to send only 2 because I can't. I need other things that require my attention, okay? Before all that, though, I would work on balancing my application. So I don't even try to send 4 streams at 720p into a single user, because that's useless. In most use cases, that's just useless, okay? So the first thing would be count pixels. I think we talked about that one. When I count the pixels, I'm going to balance the system because of that. So that would reduce a lot of the CPU issues that might arise. And then I try to figure out what would be my fallback when there is not enough CPU. The same as you would do with network. At some point, you just say no video or reduce the bit rates and resolution. So kind of the same to do that with CPU. And that means that we need to do things dynamically. I would like to have that in post-mortem to understand my application does that well, and then optimize and fine-tune, because these types of things are related not to things that are deterministic in nature. It's not that I can give you like a recipe how to do that and you'll follow the exact rules and it will work perfectly. It's more like a really heuristic. I need to figure out and to play with that until it fits my use case and scenario exactly as I need it.
Mm-hmm. Perfect. Well, Zahi, this has been a lot of great insights here. I've got a couple big takeaways from this. The first is never mine crypto while hosting a large group video call.
Definitely.
So if you learn nothing else today, take that away from it. But also that we do need to pay attention to that CPU, and that there are some indirect ways we can measure that through the GetStats API in WebRTC. Unfortunately, we're out of time, but I know that there's more that people can do too that you've written about also, like quality limitation reason, and then the kind of emerging compute pressure API as well. And so I'll refer our viewers to follow you on LinkedIn if they don't already, where you've been talking about this, and to check out bloggeek.me for more information on this topic and everything else around WebRTC. So Zahi, thank you very much for sharing your insights with us today, as always. And as I said, to learn more about Zahi's work, check him out at bloggeek.me. To learn more about future episodes of WebRTC Live, check us out at WebRTC.ventures. Thanks, Zahi.
Thank you.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.